Welcome to the DIY Honda Garage channel. The DTC P0641 signifies a malfunction related to the sensor reference voltage A circuit in the Honda Accord 2023 and newer models. The Powertrain Control Module, PCM, actively monitors various vehicle components and systems to ensure optimal performance and efficiency. If it detects that the power supply for the sensor deviates from specified parameters, it registers this issue as DTC P0641. The components involved typically include VCC circuits, such as VCC1 and VCC3, which are critical for providing appropriate voltage to sensors like the CKP, crankshaft position, CMP, camshaft position, MAP, manifold absolute pressure, and fuel rail pressure sensors. These components are essential for the engine's operation and overall vehicle performance. Understanding the precise operation and connectivity of these circuits is vital for effective troubleshooting. This guide provides a framework for diagnosing and resolving the issues associated with this DTC. DTC P0641 indicates a malfunction in the sensor reference voltage supply, primarily affecting components like CKP, CMP, MAP, fuel rail pressure, throttle body, and APP, accelerator pedal position sensors. The Powertrain Control Module, PCM, often located near the engine bay, regulates and monitors these sensors to maintain engine performance. The VCC1 and VCC3 circuits are vital as they supply the necessary voltage for sensor operations. If these components do not receive the correct voltage, the PCM flags a DTC to alert the technician of the malfunction. Proper function of these sensors is critical. The CKP sensor helps determine engine timing, while the MAP sensor regulates air-fuel mixtures. Understanding the location and role of each sensor is essential for effective diagnosis and repair. There are several possible causes for DTC P0641. An open circuit in the VCC1 or VCC3 wires could disrupt the voltage supply, resulting in a failure for the sensors to operate properly. A short to ground within these circuits would also cause a drop in voltage, leading to sensor malfunction and triggering the DTC. Lastly, a faulty PCM could misinterpret normal circuit behavior as a malfunction, resulting in erroneous DTC storage. It's crucial to perform thorough inspections of the wiring and the power connections to diagnose accurately. Identifying these issues quickly can save time and prevent further complications, enabling a more efficient repair process. When DTC P0641 is present, drivers may experience a range of symptoms that could affect vehicle performance. One common symptom is reduced engine performance, which may manifest during acceleration or under load, as sensors are not accurately sending data to the PCM. The most noticeable indicator is the illumination of the check engine light on the dashboard, serving as a warning that the vehicle's electronic system has detected a fault. Additionally, unstable idle conditions could arise if the PCM is receiving incorrect data from the sensors responsible for regulating air-fuel ratios. This combination of symptoms often leads to diagnostic efforts to pinpoint the exact cause and implement appropriate repairs. Monitoring these symptoms can guide technicians in effectively troubleshooting the malfunction. To initiate troubleshooting for DTC P0641, the first step is to turn the vehicle's ignition to the on mode without starting the engine. This step allows the PCM to start up and begin self-diagnostic checks on the various sensors connected to the power supply circuits. During this phase, technicians should check for specified power supply parameters within the VCC circuits to ensure they are functioning within expected ranges. If no abnormalities are found during this inspection, the technician can proceed to the next steps. Ensuring that the circuits are in good condition before delving deeper into diagnostics will save time and resources in subsequent steps. The second step in troubleshooting DTC P0641 involves inspecting the external circuit connections associated with the VCC1 and VCC3 wiring. This includes visually examining the wiring harness and connections for any signs of damage, including frays, shorts, or corrosion, which could affect voltage delivery to the sensors. Technicians should also perform voltage checks at the PCM connectors for VCC1 and VCC3 to ascertain if the voltages are within manufacturer specifications. If any of these circuits are found open or faulty, repairs must be conducted immediately to ensure that the sensors receive adequate voltage. If no issues are found here, the technician will need to delve deeper into the PCM connectivity and integrity. The third step focuses on a thorough inspection of the Powertrain Control Module, PCM, which is critical for managing sensor operations. Before conducting this inspection, the technician must ensure that the external VCC circuits are confirmed as normal to rule out additional electrical issues. The PCM is generally inspected by disconnecting various sensor connectors, such as the CKP, CMP, MAP, fuel rail pressure, throttle body, and APP sensors to isolate the PCM's functionality. Following this isolation, the technician should check for any stored DTCs to see if DTC P0641 persists. If the DTC does not indicate, this confirms that the PCM is functioning properly. If the DTC reappears, the PCM may require further testing to determine if it was defective. In the fourth troubleshooting step, it is essential to inspect the components that are directly connected to the VCC1 and VCC3 circuits. This involves reconnecting each sensor, CKP, CMP, MAP, fuel rail pressure, throttle body, and APP individually, while observing for any DTCs that may resurface after each reconnection. This step acts as a diagnostic process to identify which specific component may be causing the DTC P0641 to trigger. If the DTC reappears after reconnecting a particular sensor, that specific sensor or its associated wiring is likely faulty. It is critical to monitor for pending or confirmed DTCs throughout this reconnection process, as it provides insight into whether the components are functioning as intended. After completing the troubleshooting process and executing all necessary repairs, the final step involves verifying the success of the repair. Initially, the technician should clear any stored DTC codes from the PCM using a Honda Diagnostic System, HDS, or an equivalent diagnostic tool. Following this, a comprehensive test drive should be conducted to observe vehicle behavior and ensure that the previously triggered DTC P0641 does not return. During the test drive, monitoring for engine performance and any warning lights is crucial, as this confirms that the repairs effectively addressed the initial problem. If everything checks out, the repair can be deemed successful, ensuring the vehicle returns to optimal performance levels. Preventive maintenance is an essential aspect of ensuring the long-term reliability of vehicle systems, such as those that affect DTC P0641. Regular inspections of all sensor components, including CKP, CMP, MAP, throttle, and APP sensors, can help identify issues before they lead to system failures. Additionally, checking the integrity of wiring and connections associated with the VCC circuits is vital to prevent shorts or open circuits that could trigger faults. Keeping software and PCM firmware updated is also helpful, as these updates often include improvements for managing sensor readings. By establishing a regular maintenance cycle, drivers can minimize the risk of encountering DTC P0641 and maintain optimum vehicle performance for the long haul. In conclusion, properly diagnosing and repairing DTC P0641 in the Honda Accord 2023 Plus involves understanding the critical role of VCC1 and VCC3 circuits and the sensors reliant on them. Frequent monitoring of DTCs and timely identification of issues will ensure optimal engine performance and efficiency. Inspecting the integrity of electrical connections and understanding sensor operation can significantly aid in maximizing vehicle reliability. Following a comprehensive troubleshooting process is essential for diagnosing faults accurately, ensuring that any repairs made are effective. Compliance with recommended preventive maintenance will also contribute to better long-term performance, reducing the frequency of similar DTC occurrences. Implementing these strategies can help keep your vehicle operating smoothly and efficiently. Please like and subscribe to the channel. See you next time.